So today we're going to see binomial radical expressions, which means two things being added or subtracted that have square roots. We're going to work on adding and subtracting those, also multiplying and dividing. So we're going to do all of that stuff today. So first of all, like radicals are kind of like terms. So these are the radicals that have the same radicand and index. Okay, index we know is the type of root you're taking. The radicand is the number or variable under the radical. So this will be my index. This would be my radicand. And you add like radicals as you would like terms. Like 2x plus 2x would be 4x. If you see 2 square root of 3 plus 3 square root of 3, you will add the outside numbers and you will keep the like radicals the same. So this would be 5 root 3. Again, it's just like adding like terms, but instead of having variables, we'll have radicals. Now again, if they don't have the same radicand, so let's say we had 2 square root of 3 plus 3 square root of 2, those cannot be added together. They're not like terms. They're not like radicals. So since the 3 and the 2 don't match, this cannot be simplified. Okay. And again, our index has to be the same too. So cube roots, fourth roots, etc. So below we have add or subtract if possible. So check, we have the same index. We have the same radicand. So we can add the outside numbers. 2 plus 3 is 5. And we keep that radical the same, square root of 7. Do not make it 14. Okay, next one we do have like radicands and like indexes. So 7 plus 3 is 10. 10 root xy. The next one we run into a problem. Yes, they do have the same radicand, but these have different indexes. So not possible. See if you guys can simplify the next 3, if possible. Who can tell me what they got for 4? Caleb? Not possible. Different radicands. So the x and the 5 can't be done. How about number 5? Garrett? Good. And how about 6? Ashley? Square root of 7. Make sure you realize that there is that imaginary 1 hanging out in front, just like if you have an x, it's 1x. So 2 minus 1 would be 1 root 7, or just root 7. If you want to put the 1 just because it makes you feel better, you can, but it's not required. I won't take off points if you put it, though. Alright, so now we have some application type problems that are geometric in nature. Now we are going to use our algebra skills to simplify them, but in a stained glass window, as shown, find the perimeter of the window, the entire window, if each small square, so first of all, you know that they're squares,
Please excuse the
is 6 inches on
all students, all
side.
freshman students that are going to Western area today, please report to the front lobby at this time. Thank you.
Alright, so we are asked to find the perimeter of this whole thing. They tell us that this one square inside is a 6 by 6. Okay? All of them are 6 by 6. So if you notice that the edges of these are half of the square, so whenever you take a square, that's a 6 by 6, and we draw in the diagonal, what type of special right triangle is present? Caleb? A 45, 45, 90. Because a diagonal would bisect the angles from 90 into 45 and 45. So if you use your special right triangles, this should be our S root 2. So that means that the diagonal is 6 root 2. Now let's suppose, I don't know, by the time we get to our test next week, somehow you forget your formulas. How else could you figure out the length of the diagonal if you don't remember your formulas? Hannah? Pythagorean theorem. So you could do 6 squared plus 6 squared equals, let's say, just x squared. And you will have to simplify your radical because you'll get the square root of 72 and you'll have to break that down. So 6 root 2 is this diagonal. Okay. Now we need to figure out that if all of them are 6 root 2, then we need to figure out how big the sides are using our addition. So this side would be how long total? Eric? 18 root 2. And then this side would be? Sam? 12 root 2. And so we know that opposite sides are congruent. You also could use your perimeter formula, which is 2L plus 2W. Or you can just add those together. So what do we get as our final answer with units? Tim? 60 root 2 should be plain inches, because we're finding the perimeter. Alright, 8 gets even a little bit harder in terms of the geometry part of it. So this one says a rectangular window is shown is made up of 3 equilateral triangles and 2 right triangles. So we have 3 equilateral triangles and we have 2 right triangles on the edges. The equilateral triangles have lengths of 4. So I'm just going to redraw one of my equilateral triangles out here. So we know equilateral means that all 3 sides are congruent. What do we know about the angles in an equilateral triangle? Ashley? They're all 60 because triangle sum is 180 divided by 3 and we get 60, 60, and 60. Now, in order to find what the perimeter of this window is, we have to figure out, well, we know this is 4. We don't need to figure that out, Mrs. Bennett. We know those pieces are 4. Correction. We do need to figure out what the 2 little legs of the right triangle as well as the larger leg of the right triangle. Now, if you notice, this height would be the same thing as if I were to draw an altitude into the equilateral triangle. Do you see how this length and this length would be exactly the same length? So we can use the equilateral triangle, draw in an altitude, which will split my top angle in half to make it 30 and 30, which then surprisingly has another special right triangle, our 30, 60, 90. Now for any of you that are not in geometry, so I know sometimes with scheduling, we have a couple. The formula for a 30, 60, 90 is that across from the 30 is the variable s, across from the 60 is our s root 3, and across from our 90 is our 2s. So when you do this, that's what you would set up. First of all, you need to break the 4 in half. And this will actually be a pretty easy one. That'll be 2 and 2. So across from my 30 is my s, across from my 60 is my s root 3, and across from my 90 is my 2s. So s actually equals 2. All you have to do is plug it in then. So the altitude or the height of this would be 2 root 3, and that would be 2 times 2, which is 4. So if this is 2 root 3, that means both of those are 2 root 3. And we already found the base of this would have to be 2. Now we just need to add around to see what we get. So we should have 8 plus 8, which is the top and the bottom, plus 2 root 3 plus 2 root 3. Now, you cannot add the regular numbers with the numbers that have radicals, so you're going to have a binomial as your final answer. We should have 16 plus 4 root 3. Usually, like, they'll put, like, in parentheses, feet. But if you don't put the parentheses, I don't care. All right, now in the back, we're going to add and subtract where we may think it's not possible at first. But with a little simplification, we will be able to add some of these. So numbers 9 and 10, right off the bat, we're like, oh, not possible. They have different radicands. But remember, they can be simplified first. And then we can add anything that has like radicands. So we're going to, these are square roots. We're going to simplify each square root, breaking it into its perfect square. So 50 would break down into 25 and 2. 32 would break down into 16 and 2. Make sure you're bringing down the outside number as well. And 18 will break into 9 and 2. And then we take the square root of what we can. So this will be 5 root 2. Now the square root of 16 is 4. Remember that you multiply the 4 and 3 together to get 12 root 2. And then our last set, we have the square root of 9, which is 3. We multiply our negative 5 times 3 to get minus 15 root 2. And then you just add from left to right. So add the first 2 and we'll get 17 root 2. 17 root 2 minus 15 root 2 is 2 root 2. See if you guys can try the next one, and then we're going to take a look at multiplying like radical, and then you would just leave it as a binomial as an answer, like 2 squared to 3 plus 3 squared to 5. That could happen. Usually the problems are set up so that they all simplify. But all right, now we have multiplying, and then below we'll get to dividing. So multiplying, the binomial is using FOIL. Remember, if you see something, a quantity being squared that's a binomial, you do have to expand it first. And then we would just follow our FOIL process, making sure that we do the proper, let's do order of operations with our foiling in our algebra. So the square root of 2 times the square root of 2 will be the square root of 4, which then is just 2. Multiply the square root of 2 times a negative square root of 3, which will get me a minus square root of 6. You can multiply those and keep it inside the radical. Now do the inside. Negative 3 square root of 3 times the square root of 2 would be a minus square root of 6. And 2 negatives make me a positive. Square root of 3 times the square root of 3 would be the square root of 9, which then comes back down to be just 3. Now we can combine our like terms. So 2 plus 3 is 5. And this is a negative 1 square root of 6 minus 1 square root of 6, which would be minus 2 root 6. If you were to put negative 2 root 6 plus 5, that is the same answer. Doesn't matter which way you write it. It's just that usually we see a plus or minus bi, so usually in our quadratic unit we saw it written in this form. Okay. I'm going to have to skip over a couple of these. We'll skip 14. We'll do 12 and 13. So the next one has inside and outside numbers, so just be careful that you only multiply your like terms together. So we'll have 2 times 1, which is 2. Now, when you multiply right here, this is where I'll see a lot of you multiply the 3 by a 2. You cannot. You can only multiply the outside numbers. So this would be minus 10. It stays root 3. Multiply your inside numbers while I get this. Hello? I don't know. I'm in the middle of teaching. So we'll get plus 4 root 3. And then make sure that you're careful on the last one. We will get negative 20, 4 times negative 5. But the square root of 3 times the square root of 3 would be the square root of 9, which is then 3. And then we can combine our like terms. So negative 10 plus 4 would be a minus 6 root 3. And multiply these together to get minus 60. So 2 minus 60 would be negative 58 minus 6 root 3. So on your homework, when you see problems like this, I better see work and not just an answer written on a paper. You're not getting credit for your homework. You need to show the foiling. All right, we're actually probably going to skip over 13 as well. Does anyone remember what these are called? When you have one positive and one negative, it starts with a C. C-O-N. C-O-N-J. Conjugates. So these were conjugates. And we learned these when we did the irrational root theorem, where I would tell you if 2 plus the square root of 3 is a root, then you knew 2 minus the square root of 3 is a root. When you FOIL these, the middle terms are going to fall out. That's the only thing that will happen. So just to tell you, the answer for these are 2 and 3. And that's because when you do these, the middle square roots, you'll end up getting plus square root of 10 and minus square root of 10. The square roots will go away. Now the dividing. When you are rationalizing the denominator, okay, to rationalize the denominator, what you're going to do is you are going to multiply both the numerator and the denominator by the conjugate of the denominator. So normally we just multiply by what's in the denominator. When it's a binomial, you can't do that. You have to do the conjugate of the denominator. And again, the whole reason for this is that you are getting the square root out of the denominator. So if you multiply by what's it there, you're not going to get the opposite. You're not going to get rid of the square root. You're still going to have a square root of 3 in there. So for number 15, I'm going to take the conjugate of this, which would be 4 minus the square root of 3. Whatever you do to the denominator, you do to the numerator. And then you have to FOIL both the top and the bottom. So in the numerator, I'll get 2 times 4 is 8, minus 2 root 3, minus 4 root 3. Then the 2 negatives are going to make a positive. 3 times 3 is 9, square root of 9 gets me back down to 3. Now in the denominator, when we FOIL a conjugate, they should come out to have no square roots left in them, if we do it right. So we're going to get 16 minus 4 root 3 plus 4 root 3 and minus the square root of 9, which is 3. So if you did this correctly, those middle terms are going to cancel each other out. Then you just have to simplify the numerator. So 8 plus 3 is 11. Minus 2 minus 4 would be minus 6 root 3. In the denominator, we have 16 minus 3, which would be 13. And then nothing can be simplified out. The only way you could is if you could factor out a greatest common factor and divide it. But you can't. Remember, this is like a quantity. So don't start canceling things out. Okay, let's try 16 as our little closure problem. See if you guys can do it. We're going to do, again, the conjugate of the denominator. So we would have 4 plus root 15. And FOIL. So this one actually ends up not being a fraction anymore, if done correctly. The denominator should come out to be 1. which means there is no denominator left. Okay, homework is on Google Classroom.